Let's discuss parallel and perpendicular lines. So when lines are parallel, their gradients are the same. So if we look at the line y is equal to 2x plus 4, it is parallel to the line y is equal to 2x minus 7. Why? Because both their gradients are equal to 2. Why would we need this? When we write exams and when we work through questions, there will be questions where they ask you to determine the equation of the line parallel to a certain line or perpendicular to a certain line. What we are going to do now is work through an example of finding a line parallel to, for example, y is equal to 2x plus 4. Let's do that on the next page. So we are going to find the equation of the line parallel to y is equal to 2x plus 4, but passing through the points negative 2 and negative 1. If you have a look at this, you'll see that this, as we mentioned before, is your x value, and that there will be your y value. What we are going to do is substitute this into the equation y is equal to mx plus c. So there we have y is equal to mx plus c. But what did we say earlier? We said that the gradients are the same. So where I see m, I need to substitute 2. So there we have y is equal to 2x plus c. We substituted the gradient of 2 into this equation, and now we need to substitute our x value and we need to substitute our y value. Where are we going to substitute it? Into the equation here. So this is going to be 1 is equal to 2 times negative 2 plus c. So you know that 2 times negative 2 is negative 4. And what are we solving for? We are solving for c. So we transpose the negative 4. We take it over to the other side, and when we take it over, the sign changes, so it becomes 1 plus 4. And 1 plus 4 is equal to 5. And we find that 5 is your c value. So the equation of the new line that is parallel to y is equal to 2x plus 4 is y is equal to 2x, and substitute that c value of 5. Y is equal to 2x plus 5. And that's how you find the equation of the line parallel to y is equal to 2x plus 4. Let's have a look at perpendicular lines. Let's have a look at perpendicular lines. So the products of the gradients must be equal to negative 1. What does that mean? It means that when I multiply the gradients together of the two graphs, when I multiply them together, my answer must be negative 1. So if I am given, say for example, y is equal to 3x plus 1, the gradient of that first graph is 3. So the gradient of the other graph has to be negative a third. Where do I get negative a third from? I get negative a third from saying 3 times what will give me negative 1? So 3 times negative a third will give me negative 1. That's how I know that the two graphs are going to be perpendicular. So let's find the equation of the line perpendicular to y is equal to 2x plus 4 and passing through the point negative 3 and negative 4. So what do we have? We have the equation of the line. What's your standard equation? Your standard equation is y is equal to mx plus c. Now we've got the equation of this line, and the equation of this line is y is equal to 2x plus 4. But did we not say that the product of the gradients must be equal to negative 1? In other words, if I say m1 times m2, I must get negative 1. And the gradient of this line is 2. So we need to find the gradient of m2, because when we multiply them together, we are going to get negative 1. So what I can very simply do is say negative 1 divided by 2 is a half, negative a half, and fill my answer in there. So how did I get this negative a half? I said negative 1 divided by 2 is negative a half. So 2 times negative a half will give me negative 1. You can work that out on your calculator if you get stuck. So the gradient of our second line now must be negative a half. So that's going to give me negative a half x plus c. But you guys know that we need to substitute in our point. And we're going to sub in negative 3 and negative 4. So where we see y, we substitute negative 4. And where we see x, we substitute negative 3. What are we solving for? We are solving for c. So there we've got our negative 4. Negative a half times negative 3 is positive 3 over 2. And don't forget, when we take that negative 3 over 2 over, or when we take the positive 3 over 2 over, it will become negative. So we find that c is equal to negative 5.5 and y is equal to negative a half minus 5.5. Now, before we go on to the next section of functions, I just want to tell you guys that when it comes to parallel and perpendicular lines, you'll find this not only in functions, but you are also going to find it in analytical geometry, where they ask you to find the equations of parallel and perpendicular lines to the lines that they have given you. So just keep that in the back of your mind, so that when you do analytical geometry, you are completely aware that if you do get stuck, you can always go back to this section on straight line graphs to see how you need to work through parallel and perpendicular lines.